Hey guys, in this video I'm quickly going to be talking about verifying factors of polynomials. We are still looking at complex factors of polynomials in this section, and this question has given us two factors of our larger polynomial. The question states, verify that z take I and z plus 2i are factors of p of z, which is equal to 3z cubed minus iz squared plus 10z minus 8i, and determine the third factor. Okay, so two parts again: verify that those are factors and then determine the third factor. Alright, so like I've done in the previous one, I'm going to look at if z minus I is a factor, then z equals I, or I would be a root, right? So p of I equals 3i cubed take I times I squared plus 10 times I minus 8i. Right, so all I've done here is wherever I've seen the z, I substitute in my I, because z equals I for this first root or the first factor that I'm investigating. So what is this equal to? This is equal to 3i cubed minus I cubed plus 10i minus 8i. Right, now this is not as simple as the previous examples where you could just add all these terms together and they would all cancel each other out to equal 0, because ultimately that's what we're looking for. If this is a factor, then p of I should equal 0, right? But there is a bit of manipulation that we can do here, and that comes from thinking about that I to the power of 1 equals just I, but I squared equals -1, and I cubed equals -I, and so on and so on. Okay, so we can use this to our advantage. So let's think about what we can do here. We can say we can see from this part here that these I cubes are not going to cancel each other out. Let me simplify as much as I can go though. So 3i cubed minus 1i cubed equals 2i cubed plus 10i minus 8i. See here, that simplifies to be 2i. Okay, but here's where I get stuck. This is not equal to 0 at this point, but now it's a little bit easier to see how this manipulation can help us. This I cubed can be converted to a -I. So what I'm going to do is I'm going to say this is equal to basically 2i times I squared. Okay, that's just that first term plus 2i, and this I squared, well, what is that? That is equal to -1, which is equal to -2i plus 2i, which is equal to 0. So here, using this manipulation from this fact that I cubed equals -I, or I squared equals -1, I can rearrange this and I can show that yes, this is indeed a factor. Let's try that again with the second factor, z plus 2i. Alright, so once again, if z plus 2i is a factor, then z equals -2i would be a root. Okay, so let me substitute that into p of -2i, copy this down so I don't make a mistake, P of negative 2i would then equal, so we've got 3 times negative 2i cubed minus I times negative 2i squared plus 10 times negative 2i minus 8i. Alright, let me expand that a little bit straight away. I'm going to change all of this so that I don't make a silly error here. I'm just going to expand that out. So that is 3 times negative 8i cubed minus I times 4i squared minus 20i minus 8i. Right, what is that equal to? This is equal to 3 times 8 is negative 24 I cubed minus 4i cubed minus 20i minus 8i. Alright, so group the like terms together until you can kind of see a little pattern forming here. So we've got negative 28i cubed minus 28i. Now remember that this thing should equal 0, so I need to manipulate one of them. The easiest one to manipulate is this negative 28i cubed. We know that, I can write this in red here, but I cubed is actually the same as saying negative I to the power of 1. Okay, so this negative 28 is actually equal to negative 28i times, sorry, this is not negative, yes, times I times negative 1. Write it like this. So we're going to change this where we've got this negative I cubed, we're going to substitute it for negative I. Hope that makes sense. Because I cubed is negative I. Right? And just follow down with the rest of it, 28i. So what is negative 28 times negative I? This is just positive 28i minus 28i, and that is equal to 0. Okay, so this is also a factor. Again, we've used this property of I cubed. What is I cubed? I cubed is actually the same as writing negative I, so we can rearrange that and show that this is indeed a factor. Alright, so that's the first part of the question done. We've verified that z take I and z plus 2i are factors of this, but now let's determine the third factor. So what have we got so far? We've got z take I and z plus 2i are our two factors, and now there's a third factor. So when we multiply this by a third factor, remember complex numbers come in the form a z plus b. Now you can kind of see that with you know, here we've got a z and a coefficient there, and a z and a coefficient there as well. So we've got the same thing here. We've got this a z plus b form of that factor. So there is only one other factor that will make up this polynomial, because it's to the order of 3. So that must equal p of z. So that's got to equal that. Alright, and this is where we use a little bit of intuition, and we think back to FOIL. If we were to multiply these three brackets out, you would do the first times the first, and this is pretty cool. This is saying that if I multiply z times this z, and then that product times this a of z, I should get the first kind of number and coefficient here of my polynomial. Okay, this makes sense. This is saying that the first times the first times the first is going to give me my first. And the same is true when I multiply the last times the last times the last. That should give me the last number of my polynomial, as long as they are written in order, okay, from highest to lowest. So this is pretty cool. So let me write this. So therefore, z times z times az, because we don't know what a is yet, that's what we're trying to solve, equals 3z cubed. Okay, and we can see from this z times z times z, that's going to be z cubed. So what does a have to be? Therefore, a equals 3. So we've got one part of the puzzle. We've got that a of our factor. We now need to work out what b is. Okay, and this is, like I said earlier, this is going to use the last times the last times the last equals that last. Okay, so we say negative I times 2i times b equals negative 8i. Therefore, negative I times 2i is negative 2i squared. I'm going to have to simplify that and show what that is in a bit, but times b equals negative 8i. Therefore, what is I squared? This is what we wrote earlier. Okay, I squared equals negative 1. Therefore, negative 2 times negative 1 times b equals negative 8i. Therefore, this is 2b equals negative 8i. Final step here, b equals negative 4i. Okay, I just simplified by taking this 2 to the other side, or dividing both sides by 2. So now we've got a value for our a. Here's our a, and there is our b. So we have got this third factor. All right, let me write this out. Therefore, a was 3, so 3z minus 4i is the third factor of our polynomial, which is all that. Right, and that is using the factor theorem to do the first bit, and then just using this form to help me solve, and I guess a little bit of almost FOIL methodology here to try and work out what is this a, what is this b, and find that third factor